the Cisco has launched the online testing, so you can make use of this if in case you are writing any certification. Okay, so this was released, or this was announced last night. So I just thought of informing you guys, so you don't have to go to any center. You can just book your exam online. There are certain procedure here. You need to uh, produce your government IDs. You have to book the slot, and then on basis of your webcam you can just write this exam. Okay, for someone who is looking for the slot, or who is getting who was trying who was preparing for the exam. Okay, well, so you can go to this website, Cisco official website for online exam, and then the entire process has been mentioned here. So initially you have to start with your system check, and it will scan your machine, all those things, and just follow the on screen, and you're good to start with your exams. Okay, fine. So let me open the presentation.
Sagar, that means you don't need to go to any PSL center, right?
Yes, there is no need of PSN web center, but it's not been announced till what date this online exams are be available. Okay, might be this is for permanently, because all other vendors like Juniper, F5, they have their own online exams. But for Cisco, this is the first time they launched it. So it could be for few months, and then Cisco stop it.
Okay.
Okay, but as of now, you cannot go to any Pearson website. So Cisco just got the online exam concepts. Okay.
Okay, fine. Okay. Thank you.
Okay. Okay. So the topic for today is a mixture of CCNA and CCNP. Okay. So for a CCNA, guys, it would be more of the topology discussions or architecture discussion. Okay. So we would be going across with the best practice of topologies used in the enterprises. Say for example, 3-tier architecture or 2-tier architectures. Okay. So I'll discuss about each one of them. And from CCNP point of view, we will be checking out other uh, best practices. So what I have is SD access. So I'll tell you how the overlay happens over on this SD access. Okay, so this is one of the latest technology that is being used in the enterprise. But again, this works over on this one. So this is something which we have to start, and then we will come to the SD access. Okay, so I'll open up my presentation. I have all the necessary uh, graphics, so I can show you with the help of diagrams. Okay. Okay. So 3 and 2 tier architectures. So guys, who are here for the first time, beginners. So let me tell you. Let's say you get an project. You get a project from some customer. Okay, 1 second. Let me bring the presentation. Okay, so let's say you guys get some project where you need to build a complete office, or let's say you have to build a complete data center. Okay, so the requirement would be just letting you know the devices. Okay, so they would send you the device list, like something like this. This is just a random example that I'm giving you. Okay, some requirements that has come to you over email. Now, as a network engineer, or as a network design engineer, you have to understand the requirement first, the complete configurations have to be given to the field engineers who will then configure that. And from the device point of view, you must know how and what are these devices capable of. Okay, so to understand that, you need to understand what are the network architectures, or what is the network topology, or what is the best practice that we use to build any data center or any network offices. Okay, so in very simple shortcut, or a very simple wordings, I would say that your normal office setup would be something like this. Let's say you have some internet provider. Let's take it as AT&T. So they give you the internet connectivity to your office building. So you must have some router here. So this router can also be called as a edge router, or internet router, or WAN router, anything. Okay, so we call this router as a WAN router, edge router, or anything. Now this router will be connected to a Cisco switch. Let's take a very simple basic diagram. A Cisco switch. A switch will be connected to host machines, computers, printers, IP machines, anything. It can be anything. Okay, so this is how a very small office setup look like. Now the problem with this is, let's say if the link between this router and this switch went down. Okay, so all of a sudden the reachability, that is from user to internet, who used to take up this path, are down. Okay, so your whole users are now down. They don't have internet connectivity. The production is impacted. Okay, so what is the best practice that do we follow while building architecture? So we should take care of redundancy path. Okay, we must have HA failover, which is also called as high availability. Okay, we must have first hop redundancy protocols. One of the example for this is HSRP. We must have, let's say there are switches here. Okay, a standalone switches. Now this user was connected to first switch, and the first switch went down. Then this particular user is also down. So we must have some stack enabled. Okay, similar way, let's say this switch altogether went down. So how if I have one more switch which was acting as a standby? So that is a concept of VSS. Okay, so these are few concepts that makes your enterprise topology or enterprise architecture uh, more better. Okay, so that the main purpose is to avoid any outage and having at least 99.9% of uptime. This is the main goal from any enterprise designs. Okay, you don't have to, or you shouldn't fall under any outage and then it takes like 1 day or 2 day to rectify that. Okay, so that is a bad practice. So let's see what is the best practice. How does it look like? So basically this particular topic is divided into two. Okay, one is called as traditional. The traditional is one which we've been doing for a couple of years, and then we have a advanced also. Okay, so I'll just show you from traditional, then moving towards advanced. So for a traditional one, I have this model. It's called as a 3-tier architecture. It's called as 3-tier architecture. So what is the speciality of this model is, we have 3 layers. Okay, so we define this as core layer, we define this as distributed, and we define this as access layer. Okay, so these are the network devices. These are network devices, and we call it as a normal Cisco switches, the normal L2 switches, which are used to connect multiple end devices. So if you see them, these are all end devices like computer, IP phone, printer, WLC, wireless LAN controller. So these are access point. Okay, these are all end devices. End devices are connected to Cisco switches, which is a L2 type of devices. Above the switches, we have some devices kept under distribution layer. Now these are MLS switches, which is capable of L2 plus L3. I told you what is a MLS, multi-layered switches, which is capable of switching as well as routing. And these switches are connected to the core. So under core, we can use any core routers. The best practice is to use all the routers, because these routers will be then directly connected with ISP, your internet service provider. Okay. Now let's understand what is the role of each layer. Why do we use these? How is it going to help us? Okay. Okay, the functionality of core layer is to give you high speed backbone. That means, like I told you, so let's say this is a enterprise which is divided into 3 layers. This is core layer, and I'm talking about core layer. Okay, so in my core layer, I have some routers, 2 routers. Okay, or let's say I have only 1 router. Now, these routers are the one which is connected to internet services. If something happens to this router, or if the internet is down, we normally call this site has been isolated. Agree? Now, what happens if site is isolated? Anyone else who is in different location, your branch offices or your head offices, they cannot talk to you or they cannot reach to you. Okay, it's complete breakage. Your site is completely isolated. So who takes care of site isolation? It's basically your devices that is under core layer. Okay, so they must be high speed backbone. They are like a backbone. The core layer act as a backbone for these enterprise topologies. Okay, so the main purpose of core layer is to switch the packet. What do you understand by switch the packet? Now let's say I have 10,000s of users here in my access layer, and I have a core router here which is directly connected with ISP. Now if they want to communicate with another branch office, okay, now the traffic is going in this direction. So what is the purpose of core here? To switch packet as quickly as possible. Okay, if not, there will be delay. Okay, let's say if this user is downloading some file from here, if your if this core router is not able to handle the request, your file will get failed. That is what happens, right? When a quick example, like if I share you some Google Drive link and you're trying to download something over on a slow internet, what happens? You just drop that, right? Every time the connection get dropped, and then you're not able to download that, right? So who is capable or who is responsible for that? It's your router which is in that core layer. It is directly connected with the internet. So these routers which are kept in the core router should only have the routing protocol enabled. Okay, there should not be any access list or any filtering that should be enabled on these core routers, because having these will slow down the performance of those routers. Okay, so this is not a best practice to keep in a core. This we can keep either in the distribution or in the access list, or access layer. Okay, but not in the core. The work of core is to switch the packet. Anything the user is sending, switch to internet. Anything coming from outside, switch it inside to the below layers. That is the work of the core. It acts like a backbone. If the core, why is core critical? Because of the connectivity, because of the core layer devices. It's expected to provide high level availability and reliability. As I told you, if the core fails, your complete site is isolated, and until you bring this up, your site will not be reachable. Even though the users over here can communicate to each other, but they cannot communicate to the users who are sitting in other location, because that works over on internet, and the connection between internet and the router is down. Okay, so that is what it says. There should be high level of availability. We cannot depend on one single router. I need to have at least 2 best router. Second thing is, I cannot rely on a single ISP. What if these 2 routers are connected to this ISP, but the ISP link goes down? So the best practice says that always make use of 2 different ISPs. So let's say this is ISP 1 and I have ISP2. Now even if this goes down, I have connectivity to my second internet. Okay, so this is all critical scenarios, and your core layers are meant to do that. Okay, if something happens related to your WAN, then it's your core layer which has to be troubleshooted. Okay, so that is what it says: fault tolerance, failures, okay, network connectivity. So if anything related to internet or something, it's your core, and then you have to troubleshoot the core. Okay, and as I told you, don't allow any access list or filtering. It will slow down the performance, and it's only used for protocols and alternative path and load balancing. Like I told you, make use of 2 ISPs. Okay, so that even if one is down, you have other one coming up. So in a 3-tier architecture, core is about connecting to the WAN circuit or ISP. Now what is the role of this layer? Okay, so basically the main purpose of this is to interconnect these access layer with the core layer. Okay, now why don't we connect them directly? Why actually I need distribution? Can't I connect access with core? I can do that, but only the condition should be the user should not be more in numbers. Okay, if I have only like 100 users, then yes, I can connect access layer directly with core layer, and or we can also call it as collapsed layer. So when core layer and distribution layer just get collapsed, we call it as core distribution layer. Okay, so that is an example for 2-tier architecture. But as of now, let's understand what is the working behavior of a distribution layer. What does distribution layer do other than connecting core and access? So is there any other purpose? So the first point says it's a connection, or it's a layer that connect access with core. The second thing says that we can implement access list and all other filters like your QoS, ACL. So these all can be implemented on the distribution layer. The distribution layer also define policy. Okay, all your QoS policies, and include high and layer 3 switches. As I told you, your distribution layer consists of MLS, multi-layer switches, which is capable of layer 2, and also it is capable of layer 3. What else does the distribution layer do? It will properly route subnet and VLANs. Why did I say this? Let's say I have multiple users in different VLANs like VLAN 10, 20, 30, 40, and then they are connected to access switches, and these access switches are connected to some distribution switches. So your distribution switch, we can enable the concept of inter VLAN. Okay, so what is inter VLAN? By default, VLAN 10 belongs to one broadcast domain. Okay, and VLAN 20 belongs to another broadcast domain. So they are not reachable, or they cannot communicate to each other. So we need to place one L3 devices so that they both can communicate. Okay, if VLAN 10 wants to communicate with VLAN 20, then we need to have a router which can communicate, which can help us to communicate between two different routers. Okay, so this distribution layer devices are going to help us on, okay, it's going to help us on routing between subnets and VLANs. Okay, so that is your distribution layer where you can enable inter VLAN. So we will talk about inter VLAN from Monday onwards, where we will do some labs here. I'll tell you what are VLANs, what are inter VLANs, what is STP, what is VTP. Okay, so these things will come. As of now, just understand that this is one user from sales team, this is one user from IT team. So by default in an enterprise, we don't allow them to communicate, right? Sales person will not be able to access any of the devices which is belonging to IT. Similar way, IT person cannot see anything which is on a sales team. We have set some restriction. Okay, to in some condition, let's say they want to communicate, then I need to have some router which is capable of L3 routing. Now that is done over on the distribution layer. Okay, so on a core we don't do that, only on the distribution layer we do that. And all other policy based securities, access list, everything can be enabled on the distribution layer. Distribution layer will also help us in redundancy, load balancing, aggregation, and summarization. So what does it mean? So in this concept, we are talking about ether channels. Okay, ether channel is a concept where, let's say I have two switches. I have one RJ45 or one cable between these two switches. Now to increase the throughput, I can have multiple connection. But the problem with multiple connection is your STP, spanning tree protocol. It will block them. Okay, it will block the interfaces. This is a software basis of blocking. It doesn't mean that someone is going to cut the fiber or something. Your software, the software of this and the software of this will negotiate, and they will block it, and only one link will be allowed for your data communication. Now that is a huge loss, right? You just cable them so that if every link is capable of sending 1 Mbps, so you want to achieve 4 Mbps of throughput between this. Now your software is blocking everything and it is letting only one cable. Now what I can do is I can bundle it up. Okay, it's again software bundling. It's not something going and tying up something. It's just a software bundling. I'm going to configure some configuration on these. Similar way, I'm going to configure some configuration on this, and I will bundle it up. Now these 4 links will look like a single link or 4 Mbps. Okay, so this is a concept of aggregation in the distribution. Now you can send data up to 4 Mbps. Okay, similar way, load balancing, redundancy, summarization is a concept where, let's say I have 2 distribution switches, I have access switches, and I also have the computers or users. Okay, so instead of connecting like in this way, I can make use of 2 paths, something like this. Okay, even if one goes down, we have another redundancy. Okay, it also helps us in load balancing. So load balancing is also achieved here. This is giving us aggregation and also load balancing. Okay, redundancy is a factor where I have 2 devices, one goes down, I still have one path to go out. Okay, so these are the concept which comes under the distribution layer. Okay, if you see here, now you might understand what is the purpose of distribution. So we don't allow any ACL here. Okay, it's only for routing protocol and only to route the packet, no ACL. So ACLs are coming over here. All the ether channel or the throughputs are coming here. All the load balancing factors are coming here. Okay, so this is your main switching platform. Okay, it is connecting, also it is interconnecting between your access with core. Okay, so this is the role of distribution in a 3-tier architecture. Now what is access layer? Access layer is something which directly connects with the end devices. But is that only the role of access layer? Isn't it there any other role of access layer? So for that I have written some points. Okay, so one thing is it's closer to user. Okay, so if someone asks you what is access layer, so you just remember this is a layer which is very close to the users. Okay, all your access switches are connecting to end devices. Access layer ensures that packet are delivered to the endpoints or devices. Okay, so that means, let's say I have all access layer devices, and they are connecting to computers. Okay, now let's say okay, let's say this user wants to send some file to user B. Now who is taking care of that? Is it your distribution? Is it your core, right? So you don't have to reach to distribution, or you don't have to reach to core. This is your access layer which will take care of that. So basically you will send some file here, the switch will broadcast, and then it will make sure it reaches the end devices. Okay, so that is what is mentioned. It ensures that packets are delivered to the endpoint or devices. Okay, one host to another host, communication between two hosts will be all responsible by your access layer. The purpose of access layer is to physically connect users to the network. Okay, so they are physical connections between your users. It can be Wi-Fi user, it can be computer user, or anyone. It's a physical wired connectivity. There is just a cable between end user, end point PCs, and access layers. Okay, the same thing like the direct connectivity. The security policy we want to enforce in order to allow access to the network. So security policies. Okay, so you might all be knowing about layer 2 policies, right? Say, let's say I have access switches and I have the users. So let's say we can set layer 2 policies or layers 2 securities over here, saying that this port number F0/0 is binded with MAC address of this user. Why do we do that? Let's say someone disconnected this, connects this PC to this, okay, and might be this PC was infected by virus, or might be this is a compromised PC. Now we don't want that to happen. So what I do is I make use of layer 2 properties where I can bind manually. I can say that F0/0 is binded with MAC address of this user. If anything else come up, then that is violations, and the port must be shut down. It can go to shutdown mode, or it can go to inconsistency mode. Okay, so these are again something which we will see in the later topics, but just telling you what is the benefit of access layer. Okay, how access layer is helping you on a port security concepts and all. Okay, if you don't apply this on the access list, probably then it will go to the distribution layer, it will go to the core layer, and everything will get impacted. Okay, so any user directly that is connected to the switch, we can apply that port security directly on the interface. If anything violates, it will immediately cut down the communication. There will be no further communication. So your distribution is safer, even your core layers are safer. Access layer will provide layer 2 switching, high availability, port security. High availability in the sense, if I have two users, if this goes down, then this is a outage, right? So I can have another switch, and I can make sure these two computers are also connected to one more switch, so that they at least can go in this direction. Port security is something which I said, if it violates, then shut down or inconsistent mode. Layer 2 switching is nothing but all your VLAN concepts, VLAN subnet concepts, where user from 10 can communicate. Okay, so from user 10 and 10, it's all between access layer. It don't have to go to the distribution layer. But if it is VLAN 10 and VLAN 20, now this will go to the distribution layer. Okay, so that is a concept of inter VLAN. When it's between only two users of the same VLAN, like 10 versus 10, then it doesn't have to go to distribution layer. It will go to access layer. Access layer will have the MAC address table. Okay, and then it will send that Ethernet frame to the respective end devices. So the communication is only L2 switching. There is nothing routing here. And all your other things like QoS classification, address resolution protocol, and VLAN. Okay, so what is QoS? It's quality of service. Your packets. Okay, so let's say, let me give you one example. Let's say this is a traffic signal. Okay, and you have all kinds of vehicles. Now there is ambulance somewhere, so you basically will make a lane to pass it, right? So basically you're giving some privilege to the ambulance so that it can pass on. Similar way, QoS is an feature which will prioritize some packets. Okay, prioritize in the sense there are two types of packet. One is called data packet and one more is called voice packet. If I don't prioritize voice packet, all my data will be using the 100% of link. Now why my voice might get broken up in between when I'm taking Skype meeting, when I'm taking WebEx, when I'm taking Zoom, there is chances my voice will get broken up. So what is the best practice is we can segregate. I can say data should take 80% of bandwidth and voice must take 20% of thing. Okay, so how QoS is done is on a global configuration mode, we will define the policies, and on the interface, we will define the QoS interface. Say very similar like your ACL. Okay, ACL is nothing but access list, which we discussed in the previous class also. Okay, so how is access list configured?
Sagar, I have one doubt.
Okay.
The QoS is switching concept or routing concept?
It's a feature. It doesn't belong to any L2 or L3, but we normally call it as a switching topic only. But it's a feature, more or less. Okay.
But this one, okay, fine, thank you.
Okay. See, I really say that we will have Q&A after some time. Okay. So please, everyone, just wait for some slides to get covered, and then we will take it up. Okay. And address resolution protocol is nothing but mapping of your IP address with a MAC address. Okay, IP address is a logical addressing. MAC address is your physical addressing of any devices. Okay, any devices which is capable of having a valid IP will have a MAC address. Okay, it's a unique identifier number of this device. If you open up your mobile phone, there will be a MAC address. If you open up your iPad or tablet, then there will be a MAC address for that. Okay, if you open up your notebook or laptop or a system, there will be a MAC address on that. So basically that is nothing but of your NIC card, NIC, network interface card. Okay, so IPs will be binded to these NIC card. That is why that is IP address resolution. Okay, or address resolution protocol. And rest of things are your VLAN based access list, spanning tree, power over Ethernet, and VoIP. So this we will cover later on. We have this from Monday. I'll talk about power over Ethernet, and VoIP is again clear, right? It's a voice related traffic. Voice, Skype, WebEx, Zoom. Okay. Now let me tell you what is power over Ethernet. So there is a technology. Let's say I have a switch, access switch I have. This access switch is connected to one of the access point. So these access point will have external power supply. Okay, that is how these access point are powered on. So if you go back, if you just after the class go back and check your access point will have a power inlet. So if that power inlet is down, or let's say your power at your home fluctuate, your access point will also get reloaded as soon as fluctuation happen. Now that is not a good idea in your enterprises. Okay, so what we can do is this cable, with the cable which we are using for data, will also carry power. That is a technology, and your cable will support that. Your cable must support that, as well as your device should support, as well as the switch port must support that of that particular feature. Okay, it's not that only switch has that feature but your cable don't have, or this doesn't have, so then they will not work. All the three must have. So cable will have already, because they are being designed in such way. But yes, some switches are not PoE capable. If you talk about older switches, they will be not PoE capable, but nowadays lot of switches comes with PoE capable. Okay, which can transmit data and power to this access point. So for this access point, I don't need any external power supply. So as you all know, these access point are directly connected to access layer switches. So that is why this is again a part of access layer. Okay, most of you guys would have thought access layer is just about connecting to end devices, right? But it is much more rather than that. Okay, it's about all your high availability, port security, power over ethernet, spanning tree, VACLs, QoS. So there are a lot of things which your access layer is also handling here. Okay, so these were the three important layers to justify these three-tier architecture. Now if I take you to two-tier architecture, it's a collapsed version. Okay, so what we see on a three-tier architecture was two more routers which is connecting to internet. Now we don't use this, instead we are using it as a collapsed version. So where is your layer 3 or layer 3 happening? It is happening directly on this. Okay, your routing is happening directly over here. Where is your ISP getting connected? It's directly straight to this devices, and this devices is working as core plus plus distribution. And then you have a separate access layer where you have all your end devices, wireless points, access servers, all those things. Why do we use this? This is used in a small segment industries. Okay, someone who is starting up the company, they don't need three-tier architecture. They can rely on two-tier architecture. They don't have to spend a lot of money on the infrastructures or on the devices. Okay, so these are capable for switching and routing at a same time, so the traffic will be not very huge. As soon as the traffic started increasing, or if the demand, if the user numbers increase to 500, then you will see that these devices, the process. Okay, so let me tell you one thing. So let's say these were started up with 50 users and then they went to 500 users. How do we come to know that yes, now it has went above the threshold and now my devices will start failing? So how do we see that? So basic thing is we can see that from the processes. Okay, the processes will be running under the devices, so we can see each process taking up the CPU. So we can see the access list is taking 20%, 25%, QoS is taking another 20%, routing protocol is taking 60%, and you can observe that it is hitting 100% or close to 100%. And then that is an indication to say that these devices are above the threshold or reaching the threshold. Now we have to get those other technologies or other features to a core. Okay, because now this cannot handle completely the all process. So I can bring the routing to this, and I can remove the access list, all those things, or whatever is not required, I can bring it to access layer, and I can clear some processes. Okay, so that should be one indication to get you know that when is the right time to switch from this. So this is a campus design. What do you mean by campus design? A complete office setup which connects with some other branch office over on internet, or if it has another WAN service. So let's say this is a two-tier architecture. It's connecting with WAN cloud. It has some other data center or server room. It is also connecting with internet like ISPs. It also have some internet services. Okay, so this is your SD access. I'll talk about this in few minutes. Okay, so this is how your layers or campus designs look like. If you just talk about this one, if you just talk about this, then this is just a office setup. Now your office is connecting with other locations or other or I can say this is a complete overview of your enterprises. Okay, and if you see the similar diagram for a three-tier architecture, it has it has an extra layer called as core. Rest remains same. Okay, and you know that why we clubbed core and distribution inside two-tier architecture. Okay, so these are some advantages of three-tier architecture. The advantage says uh, it's a great solution for a large enterprise in the sense 500 plus users. Cisco suggests that three-tier architecture consists of three networks. Okay, the three layers. The three layers are core, distribution, access. This is more preferred design than two-tier architecture. The one more benefit of three-tier is maximum performance, network availability, and scalable. Why do I make use of the word scalable? So let's say I have multiple devices. Okay, let's say I have two devices for core and different two devices for distribution. Scaling is nothing but to eliminating unnecessary broadcast. Okay, that means let me talk in terms of routing now. Why do we use OSPF with areas? Right, area is used to scale the network. What happens if I don't make use of area? So this is a concept in OSPF routing protocol where all these routers by default belong to one area, area 0. What happens is in a multicast network, when these routers are connected to a switch, if one network goes down, that will send the LSA packets to this switch, and switch will broadcast to every other devices, and all other devices will again send back that information to the switch. Now there is a broadcast domain, or there is endless broadcast happening. So what I would prefer is I would scale this. Scale in the sense, I'll prefer putting them in area 1. I'll prefer putting these two under area 2, area 3, and area 4. Now what happens is, if something had happened on this side, other routers are not getting notified. Only the router which is sharing this area will get notified. That is called as scaling. Okay, this is in terms of routing. Now when we talk about scaling in terms of switching, L2, okay, so it's about your VLAN concepts. Okay, for example, let's say I have a switch. Switch is connected to multiple users. Now this is 10, this is 10, this is 10, all 10 VLANs. Now this is sending a ARP broadcast to the switch. Switch by default will broadcast to both of them. Okay, and both of them are going to respond, and since this is uh, destined only for this particular destination, so this will be discarded and this will be sent back. Okay, now that is broadcast feature. That is a broadcast feature of this switch. How can I reduce this? How can I reduce the unnecessary broadcast? So what I can do is I can place them in a different VLAN, VLAN 20. Now this will not hit this interface unnecessarily. It will only hit this interface which is on VLAN 10. So this is scaling in terms of in switching platform. The previous scenario what I gave an example of scaling was in routing. Okay, so that is meaning of scaling. You can let's say you built some office or you built some data center, but at some point of progress you will feel that there is a lot of noise in the network, so you would like to segment that. Okay, so segment would be the right word to define this. So that is scaling. Now that is more helpful when we have three different layers, right? I don't have to mix up ACL, I don't have to mix up QoS, all those things. So every layer has its own plus and minus, or every layer has their own predefined sets. Whereas in this case we don't have that. We only have two layers. I have to do ACL, I have to do routing protocol, I have to do every other features uh, on this on this, and whatever I have defined for access will be on directly on this. Okay, now there will be some time when this, so the feature or the process will start consuming a lot of CPU or the resources or the overhead. Okay, we call it as overhead. Overhead is nothing but CPU plus memory resources on these devices. So we will see that they're getting exhausted, and we can see issues like slowness, packet drops, interface drops. So these are all default things which will happen once we see these things. Okay, so this is a two-tier architecture. And what is the features of two-tier? It is small to medium. Core and distribution are combined, called as collapsed. Collapsed core is when distribution and core are implemented by single device. Okay, so we just saw, now we don't need a separate router which connects to internet. Your core is only connecting to your internet. So that is what it says, by single devices. The primary motivation for the collapsed core is to reduce the network cost. Yes, because a company which is falling under small to medium, they will have a fixed budget. They cannot spend on multiple things, so they will prefer a smallest or very least cost network designs. Okay, and in two tier still maintaining most of the benefits. So basically, in terms of benefit, yes, we are maintaining the benefits, but one point of time, this features or whatever process is running will get over exhausted or below above the threshold, and there is when you have to move from two tier to a three tier architecture. Okay, this is regards to the reason for having these hierarchical designs or a hierarchical network designs or these topologies. Okay, so go through this. We have already discussed most of these things, why we need three tier, what is the use of two tier. Okay, so I'll just quickly go through this. It's dividing the enterprise network. Each layer will implement specific functions. Each layer will be called as modular layers. Okay, and these modular layers are easy to scale the network. Okay, if I have to remove ACL concept from core, I can remove it and I can put in the distribution. It makes me easy, but in two tier I cannot do that. A fully meshed network. What is fully meshed network? Let's say I have these kind of designs. Full mesh is a concept when all the devices are connected to each other. Okay, something like this. This is a full mesh. Okay, when all the devices are connected to each other. Now this is a highly expensive because you need so many cables to connect everything. Okay, there cannot be any cable left out. All devices must be physically connected as if they're face to face. Okay, so in a these kind of model, like in a three tier architecture, or especially in three tier architecture, we don't have to do, the core is not directly connected with access layer. In between there is a distribution layer, right? So that is what this is telling about, that we don't have to follow full mesh. We can follow, we just have to go accordingly. It will be cost effective. It will not going to be very expensive. Hierarchical design will provide fault containment. Okay, constraining the network changes to a subset of network which affects only fewer system and make it easy to manage. That means, let's say I have three tier architecture. These are the routers, core routers connected to distribution switches connecting to access layer switches, and access layer switches connecting to multiple users in the sense multiple network of users. Let's say this is 1.1.1, this is 2.2.2, this is 3.3.2, this is 4. Now let's say I'm doing some changes on my router. Okay, changes like some routing protocol, I'm some protocols I'm adding up, or some protocol or prefix length I'm advertising on the core. Okay, so other networks are not getting impacted. Okay, so basically if anything is over here on this, let's say if something is configured here, so other things are not getting configured because other things might be configured on your second box. That is what it says. In a hierarchical design, the advantage is the subset of network. The network will not be affected. Okay, only very few systems will be affected. Let's say this is gateway for 1.1/24, that is this. So only this system might get uh, have some impact during any upgrade plans or during weekend activity, but other users which are hosted on this, they will not even have any impact. They will work as it was. Okay, so that is what happens when we have three tier architecture, when we have things splitted up. Okay, network components can be placed, taken out of service with very little and very no impact. Basically the same thing. What it says is, when I have multiple devices kept in redundancy. Okay, So this router will have one more router acting as standby, and this router will have one more router acting as standby. This switch will have one spare switch acting as a standby switch. This switch will get another switch which is acting as a standby. Now if some issue is going on with this, I can remove this, okay, but I can make sure the cable is injected on this, and similar way on the upstream I have the cable injected to this. Now it's very easier for me to remove any faulty device because I have redundancy in my device, in my uh, 3-tier architecture. That is what happens in a hierarchical orders, right? So it is easier for us to replace or plug any faulty devices, something like that. Okay, so this is when we talk about access layer. Okay, we discussed core layer, we discussed distribution layer. Now it's time to discuss about access layer. How is access layer looks like? So there are two models, or there are two ways. Okay, one is, let's say I have same VLANs. When I have same VLANs, so let's say this is a access switches. Okay, so this is a access switches, and these are some switches which are connecting to host. Now the chances are, due to the spanning tree blocking, your one of the interface will be taken down, something like this. Okay, so this is happening in access layer, and when we have two different, then there will be no blocks, it will be loop free. So why did I include this? Is this is a STP based of access layer. When I have STP, now most of the company don't want their network to be blocked. Okay, so let's say if I don't have STP enabled here, this is expected that all the interface are forwarding, they are forwarding in nature. But the problem is, if there happens to be any looping, that is a problem in your access layer, and by default you have to keep the spanning tree enabled. As soon as you keep spanning tree enabled, you will see two links gets blocked. Okay, so to avoid this, we have one more approach in especially talking about access layer. Okay, the approach is routed type. So let's say I have a routed access type. That means instead of VLAN, I have all the IPs configured. I'm talking about access layer. Okay, not about the distribution, not about the core. In an access layer, I can have the IPs. Now what happens is, what are the benefit of having IPs and not having VLANs is, I don't have to make use of any HSRP or VRRP, because okay, so let me give that example. What is FHRP, or this is first hop redundancy protocol. The two example for that is HSRP and VRRP. Okay, so let's say when I have two routers, something like this. Okay, so let me say this is a MLS, this is this. I have one switch, layer 2 switch. I have a host machine, PC1. Now this is connected to this is connected to this, and this is how the traffic is going every time. Now all of a sudden this goes down, there will be some delay for your traffic to fluctuate and go take the other route. Okay, so what I do is I enable FHRP, I enable HSRP. Let's say I have enabled I have enabled HSRP. So when I have enabled HSRP, I am going to make use of some logical IPs. Okay, so this logical IP will be in this network. Let's say this is 1.1.1.1, this is 1.1.1.2, and this logical IP will be 1.1.3. Okay, now this IP will be configured in the gateway of this computer. Gateway of this computer. Okay, I guess we are good with audio. Okay, so this user machine will have the gateway 1.1.3, that is the gateway of this logical HSRP. Now when the traffic is going, it is binded with HSRP IP. Okay, it's not binded with either this, neither this. Traffic is good till it's all up and running. If it goes down, it will not take any single extra millisecond to divert the traffic and go this. So it's basically reducing the delay or reducing that diversion. Okay, so that is the meaning of HSRP and VRRP here. In this kind of scenario, I don't have to make use of any HSRP, but in this case I have to make use of HSRP because these are two switches. I have to make use of HSRP, but in this case they are all IPs. So if they are all IPs, what I can do is I can enable routing protocol. I can directly enable OSPF, any routing protocol directly inside access layers. Now this is something interesting. You may not have heard that because normally access layer will be all VLANs, but in some production or in order to advance your access layer, we also make use of routing protocol straight away on the access layer so that we don't use HSRP. The convergence speed is more and we don't have to go through the STP. Okay, there will be no blocking. So all my ports are forwarding now. So there is no blocking in this kind of access layer. The uplink utilization is increasing. So what it means is, let's say in the STP scenario, this has two upstream. One is this and one is this. Similar way, from point of this, it has two upstream. One will be getting blocked on both of them. So only you are left out with one upstream. But in this case, you have both the upstream forwarding. That is what this point says. Increase uplink utilization and easier troubleshooting. Why easier troubleshooting? Because when you make use of ping and trace route, okay, so let me tell you, these are the network troubleshooting tools. Okay, I'll take a dedicated class for explaining ping and trace route difference. Very important thing. Your whole network area is pinging on taking trace route. Whenever you go into some troubleshooting call, or normally in normal general scenario also, the first thing you do as a network engineer is ping the device to see if it is reachable or not, then do trace route to see what is the latency happening. Okay, so that is what even I am running here. I'm running this ping just to make sure that I am reachable, I am not having any delay or latency, right? So this is something which I will tell or I'll explain theoretically. Okay, so very important, every network interview will be these questions will be asked. What, how ping works, how trace route work, what is TTL, what is RTT value, what is ICMP code 8, what is ICMP code 0. Okay, so you should know from interview point as well. So I'll take one class where I'll discuss those. For now, just take this as a network troubleshooting tools. Okay, so let's say I have a computer here, a PC or a computer here, and if I want to ping B from A, so I'll say ping 1.1.2. So basically that packets will be sent in this direction and I get the response. Okay, since these are all layer 3, I don't have to worry about trace route because they will be all end to end connected, right? They are all IP based, so I will immediately get the response. In this case, what happens is there will be problem with trace route or there will be problem with ping. If in case if there is a STP loop, your ping will be keep on rotating. There will be only loops happening. Okay, so in a routing access layer, you don't have to encounter any loops because they are loop free. Okay, and they are directly connected. So basically it is single hops away. Hop is nothing but distance between one device to another. So this is called a single hop. Okay, this is a single hop away. Okay, so this was regards to the access layer designs. Okay, and this is simplified campus design. So what is simplified campus design? If you just talk about this one, this is a complete 3-tier architecture, but this is not simplified. Okay, simplified in the sense I have kept two devices here. I am making use of two separate devices here, right? There will be issues like STP. There can be issues like uh, aggregation here. There will be very less aggregation here. One will be serving the traffic, one will be down at a time. Okay, so what we can do is we can bring some technologies. We can bring some advanced technologies like stacking, VSS, virtual switch. This is stacking. So basically stacking is used in the distribution layer. Okay, like your Cisco 3750. We make use of the technique, a technology called stacking. So when I have like two switches, I can keep them one over another. I can plug the cables. Okay, now one becomes master, second becomes slave. So master, in the sense, master will control, will have the control on the control plane. Okay, control plane is your brain that we discussed in the previous class. It will decide about routing, all those things. So master will have control on control plane, but at the same time the data will be active on both the side. That means all the interfaces will be active. It's not that concept where only master is serving and slave is just idle or standby. Okay, and when the first device goes down, then this comes up and then it starts serving. That is not the concept of stacking. Okay, stacking is a concept of aggregation where I am making one master out of two. I will make one master. It will control the plane. It will have the control on the control plane, but the second device, which is acting as slave, will have a active data plane. Both will have a active data plane. So if the first device has 48 ports, the second one has 48 ports. So basically you are having 48 plus 48, these many active ports. That is the meaning of stacking. Okay, it's not about keeping one standby and only 148 is using. Then that is not a best practice. We are trying to eliminate all those things like STP blocks, anything which is not giving us the potential of that device. Then that is a unwanted loss for us, right? So we have to use the devices to its potential. By if I keep one device on a standby, then I'm probably not making use of best practice. Okay, so that is stacking, and we use this stacking specially in distribution switches like Catalyst 3750 or Catalyst 9300. So they are all supporting stacking uh, stacking features. Similar way, this is a virtual switch which where this is specially used in the core layer. Okay, so as I told you, in a core layer, if I have two Catalyst 6500, I can just connect one virtual link which is called as VSL. Okay, it's a virtual switch link. Now what happens is the same concept. One device will become, or one device will control both the device, and both the device will have a data plane active. Okay, so someone who is on a downstream will see this switch as a single switch, something like this. There were two switches. Once you enable the concept of VSS, this person, this two switches will see them as a single box. Okay, now you enabled stacking on this. Now once you enable stacking on two different switches, it will look like a single switch to this PC user. Okay, now what is the advantage of this simplified network? Your traffic is straight away going to this, and it's going to this, and it's going out. In this case, traffic will go here, it will go to this, it will go to this. Okay, there is chances this traffic will come back to this, it will again come back to this. Similar way, this traffic will come back. There is unwanted broadcast happening. Okay, which is creating overhead on every devices, which is why we are simplifying this. In this scenario, there is no second devices. Even though there are second devices, this PC will see only as one single. So this will send the traffic to this. They will decide who will forward the traffic, because out of two, one is controlling. So it will say, this is this happening, this is the routing, let's go via this. and then it will forward that packet to the VSS will perform the similar concept, and it will send it to ISP. Okay, so very less impact on the devices. There is very less uh, broadcast happening. Okay, broadcast. What is broadcast, by the way? Broadcast is a terminology, or it's a method of communication where one node can speak to multiple persons at a time. This is a broadcast. What is unicast? Unicast mode of communication is one to one. Okay, if this person know that I have to reach this person B, it will directly send that communication to B. In this case, this doesn't know whom to send, it doesn't know whom to reach, so it is going to send everyone by default. Okay, that's called as broadcast. That is not a good thing in a enterprise. It is unnecessary creating overhead on every devices. Okay, so we try to keep unicast. So basically on this scenario, it's like unicast packet, a single packet hitting everything and going out, whereas here it's a broadcast. It's going across on the interface and coming back, and then we have the STP blocks. Unwantedly we are blocking one of the good interface so that we don't end up with loops, and then you know what happens in enterprises. Okay, fine. A quick revision on simplified design. So basically there is no need of redundancy because we are using a unicast medium. There is no STP here. Uplink gets increased because of the ether channel. Okay, what is ether channel? I told you, when I have two devices, when I have multiple cables connected between them to achieve more throughput, if all are 1 gigabits per second capable, so I'm connecting 4 so that I can get 4 gigabits per second, but due to the STP my 3 links will get blocked, only one is serving. Now that is not a good reason, so I will make use of ether channel concept. I will bundle them out. Now what, how does it look like? It will look like a single link. Even though there are 4, it will look like only single link, and this single link will be capable of 4 gigabits per second. So we have a lab, we have a dedicated class, so we will see in that. It's easier to troubleshooting, faster convergence, and distributed VLANs. Okay, so we have multiple VLANs, multiple access switches without any blocking any of the links, all those things. And faster convergence is a concept where all the uh, links are in forwarding. Agree, there is no STP blocking happening, so it's all forwarding in nature. Okay, so this is a full scale diagram of VSS and stack in a campus network. Okay, so we have stack in distribution, we have VSS on core, we have VSS again. Okay, and all other things. If you go back to the 3 tier and 2 tier, we have seen more focused on 3 tier or 2 tier. Okay, in this we are focused on the simplified versions, or and giving or making use of the advanced concepts of VSS and stack wise. Okay, so any doubt over here, all the traditional methods?
Okay. I think I have a couple of questions.
Okay.
Okay, the other one, I think it has been clarified by that diagram, because initially you were saying you have the stack, you can have it on the on the access layer, and I think that's for increasing throughput and the number of ports. I think that's where it's most important.
Okay.
In terms of the connections that you need there.
Okay.
The other one is on the scale. When you were explaining the scale, you were talking more of about the broadcast. I don't know. I'm not sure whether it's okay. I feel that yes, with scaling, you need to deal with the broadcast in order for you for your not to having to maybe invest in the network. For example, okay, if you can increase the traffic.
Okay.
Because you would have eliminated the broadcast.
Okay.
I don't know whether my thinking it's the best, because I think it's all about having to grow your network, invest more.
Okay.
The other one is whereby you were talking about the QoS.
Okay.
So the access layer, you apply QoS at the distribution layer. So what I want to find out is what's the difference? Is it not supposed to be applied at a single layer? What when you apply it at the core layer? What's the difference there?
Okay.
Okay. The other one it's on collapsed core, collapsed layer, core and distribution. That's where you now, it means you have to combine a lot of features. You need to do ACL and filtering. So what is the impact on the performance?
Okay.
And the final one now, it's on the if you look at that, there's the campus diagram.
Okay.
I see that the firewall is just placed towards going to the internet. So, and if you are to maybe block certain users from accessing certain servers on the data center, do you steer traffic towards the firewall and back to desire to apply?
Okay. So see, I'll just answer few of them, because if you keep on asking, might be then I might forget what are the questions. So fine.
No,
Okay.
it's okay.
So
No,
see, this
okay.
is just an example diagram. Okay. This is not a diagram of any companies or any enterprises. So yes, if you see some
Okay.
firewall here, it's just to let you know that these firewalls are kept closer to ISP. Okay. It doesn't mean that we cannot place any firewall here. This is not any standard diagram for any enterprise. This is just an example to show you these things, especially these things. I'm not at all focusing on this part. Okay. So that was the intent of showing this diagram. But if yes, you are asking from firewall point of view, this is placed close to ISP, because as you know, your packets will be inspected. Now yes, if you want to have packet inspection between these two, yes, you can have firewalls placed here. Okay. So that is something which comes, or which will be decided by the network design engineer. But yes, of course there will be firewall, because if you don't have any firewall, all the users by default will be able to communicate to this, or these might be able to ping any server or communicate to any server. So basically I would like to keep two firewalls here, so that I block the communication, and if something is required, then I will permit that. Okay. So this is the answer for one of your question. And the second question that I remember is about the QoS. So you said, why don't we use on the core side, instead why do we use on the access side? Okay. So we are tuning the traffic of our users. Okay. The users who is attending Zoom conference, or a user who is attending or who is sending some file. So basically that is hitting on this interface rather than tuning it over here. Okay. Because this traffic might sometimes be only within access.
Sorry, let me clarify my question. I was saying, why are we doing it on two layers? Because we talked about having to do QoS on the distribution and having to do it on the access layer. So I was just only saying, can't we do it on one layer?
Yeah. So we are we are doing it on access layer, not on distribution. Okay. Might be that is something misread or something. Thus QoS configuration and the access list configuration are pretty similar. So basically you have to first define and then you have to implement on the interface. So there are two steps for QoS. One is to define, second is to implement. So the implement is over on this interface, or this interface, which is directly connected to your host machines or your computers. Okay.
Okay.
So are you sharing your screen with someone, because I can hear some background?
Pardon?
Are you sharing your screen with someone?
No,
Because I can hear someone talking in the background.
no, it's not from my side.
Okay. So do you have any
It's
other
not from my
question here?
side. Okay. No, the other one that I was asking was it was about the impact on performance, because now it will mean that your routing and your ACL
Okay.
will be applied there also, filtering.
Yeah. So if the performance is not impacted if your users are in less numbers, okay. But yes, performance will start degrading once the user cross the threshold, because then your distribution collapsed layer, the distribution and core, have to handle both of them. Okay. So that is depending upon the user counts and the user traffic. So if it is within the threshold, the, it is as good as normal behavior. But as soon as user count increases, this will start impacting.
Mm.
Okay. So any other questions, guys?
Yes, sorry, I have a question
Okay.
here on the core side.
Okay.
So you said there should be no packet manipulation such as access list.
Okay.
So if my core is connected directly to my ISP,
Okay.
it means though the core is connected directly to the outside world. How I'm gonna secure that if I don't do any access list?
Okay. For that purpose, you are using the firewalls as soon as. So your core routers are not going to do access list here. Your core routers are going to
Okay.
only forward the traffic to ASA, and then ASA will take care of it.
Okay.
Yeah.
Okay. So you mean I'm gonna have my core connected directly to the ISP?
Yes. So there are two ways now. There are two ways. Because some companies prefer router on the core which connects to ISP. Some wants to eliminate
Okay.
this and directly connects to firewall and enable routing here.
To the firewall.
Yeah. Now again, that's based on the user traffic, because if you start uh, giving all the features on ASA firewall, especially like routing, uh, inspections, all those things, then probably your ASA will start getting exhausted. Okay, so some companies prefer
Exhausted.
keeping routing separately on a ISR router or ASR router. So the work of those routers are only to connect to ISP and forward the packet. That's all. They are not going to do any other kind of manipulations or any inspections.
Okay. But the router that is connected directly to the ISP, they are open to the outside world, correct?
Yeah, that is fine. They are open to outside world, but later on they are directly connected to the firewalls, right? So your main things to
Okay.
secure is your servers, not the routers here. So the main thing is your softwares or your application that you have loaded up on the servers, okay, which is what of a worth
Ah,
here. So if someone reaches till here, then that is of a risk to your enterprise. But if someone is over here, if he's at the most, what he can do is he can create some DOS attack or a DDoS attack. That's all. He cannot do anything else on these routers. So he can generate a
okay.
lot of TCP SYN packets, or he can generate a lot of ping death packets, so that your routers fail eventually. So that is the maximum attacker can do. But other than that, he cannot come till your servers or the softwares where you have hosted up.
Okay. All right. Thank you.
Yeah, no problem. Okay, guys, I'll quickly go through SD access, then we will take up this Q&A. Okay. Okay, so far we learned only the traditional ways. Okay, the ways by which we can place this devices in 3 different layers or 2 different layers. Okay, in order to uh, have it. So the all reason to use these 3-tier or 2-tier was to have fault tolerance, to redundancy, for a high throughput, for maximum uh, packet flow, all those features, right? Now, keeping them in the mind, if I place a software on top of it, okay, I'm still making use of the physical devices, but over on that, if I keep some software provisioned, and this software is giving me graphical interface to track what is happening in this network, like what is the application consumption, what is the user, what how many users are there, how many users are connected to wireless. So that is your SD defined access. Okay, so this was a simplest definition for software defined access. So in software defined access, it's not something take out the traditional way and get something on a software and recreate. Okay, it's not that way. You're still falling, or you're still following all your traditional ways, like your 3-tier architecture or your 2-tier architecture. The only additional component is getting the software defined applications, and then you are taking the control of all these devices via this software. Okay, even to configure any devices, you don't directly have to log into this. It will be from this software, and this software can do the job. Okay, so let's go to the next presentations, and I'll show you in much more depth what is software defined. So what is software design? It's combination of campus design along with digital network architecture center, which is called as DNA or DNAC. Okay, now this is a concept which is introduced for the first time. Or might be this is still in a testing phase, or might be this is still tested on 50 enterprises. Okay, you will not see this technology integrated with every enterprises. This is coming up. Okay, the software defined access is all coming up. They are getting tested up, and as the importance or as the benefits are getting increased, enterprises are preferring to keep them. Okay, so how does it work is so basically you have to have your campus design, and over on that you are going to add this. Now what is this? Is it a hardware? Is it a software? So basically this is a hardware. This is a hardware which will look like a switch, and this will have your all graphical management access. Okay, so I'll show you some screenshot after some time, but just understand from the point number 1, it's all about combination. SD access is not about taking out the traditional and getting the new things. It's keeping the fabric design, or it's keeping the campus design, and you're bringing a new hardware. Okay, now this is called as underlay. Okay, this is the terminology that we use in SD access. Underlay is the bottom layer, and this is called as overlay. As I told you, your traditional technology will be here, and you're adding a layer on top of that. Okay, so this software layer will be called as overlay, and this underlay will be the bottom layer, which is traditional campus, will be a underlay design. Okay, so the second point says that SD access add fabric capabilities to the enterprise, automating SD access technology, providing automated end-to-end segmentation to separate. Okay, So let it come up, okay, and then okay, looks like it has come up, okay. So SD access is all about automating your end-to-end segmentations, okay, application traffic, your network design. I'll go about this in few minutes, okay. So what is the main features of a SD access? So basically SD access deal with host mobility, okay. Host mobility is nothing but your users in the enterprises. They might be wired connected, they might be wirelessly moving from cafeteria to desk, or from desk to some tea break or something, right? They will have their own phones connected. Now let's say a wired connected user has some different policy, and the user who is connected on wireless has different policy. Now there will be a lot of mess in this for troubleshooting, or this will create a mess in this, okay. So with the help of software access, I can make a provision that everyone, the wireless, wired, everyone have a similar policy throughout the network, okay. That is what this is referring to. Along with, see, the extra features that you get here is your security. You can maintain the security, okay. You can make use of the host mobility, that is wired and wireless get the same policies, not that one gets something, other one gets something. So these things will be taken care by this, along with your normal routing and switching, okay. Your normal routing switching is not impacted. It is still be taken care by the SD access the way it should be. And yes, regarding the word overlay and underlay, so your fabric network, which is called as overlay network, this is the campus network, okay. Fabric network is your virtual network which is built over on underlay network. So this is your campus network, which is a physical network. And how is the synchronization? So let's say this is my underlay with all the devices. On top of this, I have kept overlay technology, SD access. Now, how is these two synced up with the technology VXLAN? Okay. So let me tell you what is VXLAN. Normally, you might have heard VLAN. VLAN, what is VLAN? Separation of infrastructure, or creating multiple broadcast domain, or grouping of users based on different broadcast domain. Now this is called as VXLAN, some advanced topic than VLAN, right? So let me go to the next topic where I have regards to VXLAN. Okay, regards to VXLAN. So let's say I have one data center here, data center, or let's say this is a remote site, Scotland, and I have one more site in India. Now I have users in different VLANs. Let's say VLAN number 500, VLAN number 499, VLAN number 498. Similar way, the same VLANs I also have over here, 500, 499, 498. Now if I want to extend my VLAN from this to this over on the internet, okay, they are different site, they are Scotland and India, and they are connected over internet. Over on internet, I am extending my VLANs. That is why it is called as VXLAN, extending, okay. So what is the use of VXLAN? So basically the user from this VLAN can communicate with the user of this over on the tunnel. Now you might be thinking, do we need VPN for this, site to site VPN? If VXLAN tunnel is capable of extending the VLAN from this data center to this data center, so that they belong to the they can communicate to each other. So do we need VPN, or is VXLAN something very similar to VPN, or VXLAN, is it VXLAN similar to VPNs? Okay, so let me tell you, VXLAN and VPNs are two different things, okay. Both rely over on internet, but VPN has two protocols. One is ESP, encapsulation security protocol, and authentication header. So basically on this protocol, your encryption and authentication is taken care, but AH provides only authentication. Okay, but both the protocol is also encrypting the data, whereas in VXLAN it's only about adding to UDP packet, but data is not encrypted. Now you cannot send the data over on internet without any secure medium. So the best preference is enable your VPN like IPsec site to site VPN, and then configure the VXLAN so that you can extend these two subnets on two different data center. Okay, so this is a concept of extending the VLANs, the layer 2. Okay, the actual definition of VXLAN is here. It's basically you're encapsulating the layer 2 packets inside layer 3. Okay, and then you're sending it across the tunnel. So your layer 2 packets get injected to the layer 3 technology, and then you take it to the next data center. So this is a technology that we use in the SD access. Okay, where do we use this? Between this overlay and the underlay, there is some integration needed, that is your VXLAN. Okay, and to explain what is VXLAN, I just gave you this slide presentation, so you know what is VXLAN and what is the working nature of VXLAN. Now if I go back to the slides, so as I told you, there are two things required for SD access. Okay, what are the two components of SD access? One is called DNA center, digital network architecture, and second one is your fabric campus. So now we have already checked this can be 3-tier architecture, 2-tier architecture, all other things like STP access list or routing access layer. All those things are part of this. Now what is DNA? This is something we are hearing for the first time. DNA, is it hardware, is it software, how does it look like, what is the way to configure this, right? So let me show you some presentation for DNA especially. Okay, so DNA is a box, it's a hardware box. These are DNA, and this is the way you configure the DNA for the first time. The best preference or the best practice as per Cisco is keep 3 DNA hardwares. This is the best practice. If you read the documentation for a Cisco DNA, the Cisco says we need to have 3 DNA hardware as a best practice. Then you will configure the required things on the DNA center, and that is how you will bring up the DNA box. Now once the DNA box is up, what is next? What do you expect on this? Okay, you will be expecting these kind of graphical interaction. Okay, now what is this showing us? So if you see this, this is a DNA center, and if you see this, these are the device that is being discovered by the DNA center. Now what are these devices? These are your devices which is falling under the fabric 3-tier architecture. Okay, it started pulling up those devices. So let's say these are the campus design, and you have the overlay. As soon as you have the DNA configured, and as soon as you started building up the integration, over on the DNA graphical interface, we can see these devices getting readable or getting polling up here. Okay, so these devices start polling up on the DNA center, and we can see all the devices like firewalls, core access, routers. We can see the access point. We can see we can see the IP address. We can see the reachability. We can see what is the uptime of those devices, when was it last updated. Okay, so these are the first page overview. Now regarding this geographical discover, okay, so let's say the DNA is integrated with your multiple locations. So on a world map, you can see these kind of notations. Now let's say here there are more than 10 devices which are down or unreachable. Then you can see it on your graphical mode that yes, this site has a highest number of unreachable devices. If it's green, that means all the devices of that region are green. They are reachable to the DNA center. If there are orange, that means there are 2 or 3 or 4 which is not reachable. Okay. Red also resembles isolation. If the complete site or complete devices are out, okay, then we see this. So let me walk through few of these slides, and then I will tell you what is the purpose of DNA, introducing DNA. So this was one benefit, or this was one slide or one presentation where I can see on geographical basis, as well as I can see the device uptime, IP addresses. If I see the second benefit, I can see my DNA center will automatically make the topology. Okay, this is automatically created. It will categorize everything, your routers, your switches, and based on your locations like US location, Netherlands, Mexico. Okay, so you can see this is a core devices, this is distribution, you have all the end devices. So everything start getting created automatically. It's not a manually done. So this is one of the second benefit. Now let me show you one the other things. So let's say this is the third benefit. Now you can see the overall health summary of your clients. You can see what is your network is all about. It says 82 healthy devices. You have 100% core switches reachable, but you have some access switches not reachable. So only 63 are reachable. Okay. Now from this you can easily start digging in, and you can see which device is down, what is the issue there, do you require RMA, do you require any VLAN to be configured, what exactly is happening. Okay, so this overview will give you the network health. Now similar way, what is this is a overall health of your client, and also it is okay. So basically it's the same slide. Let's go to the next benefit. Next benefit over DNA is about the network health. So you can set some timings. Let's say you need to take the captures for the last 3 hours, 24 hours, 7 days or something, and then you can get to know what is happening there. Okay, so these are the devices versus time. So how many devices down at a moment of time, for last 7 days how many devices were down. Okay, so basically device or your network health. Now this is regards to your device role. Okay, it is going to poll your access layer, wireless layer, core layers, distribution layer, and routers. It is also going to poll your system health, data planes, control plane. So this is all the benefits that DNA center is going to give you. And why our company preferring this? Because the monitoring of their networks becomes very easier. They easily come to know where is the fault and they can fix it, instead of the network engineer finding out the culprit or finding out the device that's having an issue. Your graphical says clearly what is happening. So see, if in this case it says clearly what is the data plane connection at this moment. Okay, how many wireless devices are down, what is the health of a wireless category, right? What else can we see apart from this? So apart from that, we can see the access point also get triggered up. We can see the access point health, as well as if let's say I have 100 of access point. Now I can see every access point bandwidth utilization, users connected to that, is the access point down, is the DHCP down, everything on the DNA center. So DNA center is an all-rounder for in terms of wireless security. You can also impose the security. If there is a port security missing, you can push that configuration directly from DNA center. You don't have to troubleshoot, get that device, then configure the port security. It's all clearly and very easily can be done from DNA center. Okay, and how do we poll some new devices? Let's say I need to poll any devices. So DNA center will help me, or it will give me the provision to discover on basis of site or building. Let's say I have one site with 2-3 buildings and I would like to categorize them. Let's say I have building number 1 with 100 devices, with building number 2. Now I can create a profile for that and then I can poll the devices. Then this is again the designs. This is regards to the wireless wired connectivity and the AP clients. Yes, and regarding to the troubleshooting, okay, as I told you, what is the normal day-to-day activities of a network engineer? One of the activities is to troubleshoot the issues, right? Over on DNA, it is not just about monitoring, it's not about pushing the configuration. It will also help me to troubleshoot. Okay, at least basic troubleshooting can be done. Basic troubleshooting in the sense, if I get an alert saying OSPF agency failed on so and so device, on so and so neighbor with this neighbor IP. Now it is giving me some suggestion. Now, who is this required for? Is it required for a network engineer level 2 or level 3? It's not required. But yes, it might be required for a network engineer who is in a level 1. Similar way, it might be required for a manager level of person who has the access to DNA. Now these guys can also do the basic troubleshooting. They can see this DNA center recommends ping the neighbor IP first to verify connectivity. Now if we click on this, the prompt will start and it will automatically start pinging up. Next it says check the OSPF neighbor. He don't have to run the CLI commands. He don't have to remember show IP OSPF neighbor is the command. Now even a layman can do the basic troubleshooting. He can just use this run command and the OSPF neighbors will be captured. Okay, it will show me which is down, which is up, what is the result. Now from a point of L1, he can send us an email saying that so and so troubleshooting I have done and I have found that this neighbor is down. Please take it forward. Now the work of L2 and L3 will be simplified, right? They don't have to do the basic troubleshooting of going to device, seeing this basic ping, OSPF, all those things. That is already done and done by the L1. So what is happening is your SLA is in a time, right? So what is SLA for a company? Let's say if it is a P1 case, a priority 1 case, basically the SLA will be very critical, only 5 minutes. And in this 5 minutes, you have to log into the device, you have to do the basic troubleshooting and you have to inform the customer. Now, sometimes to find out the device IP itself take 5 minutes and then you start logging up. Sometimes your radius or TCAS don't work. Now, it will take 15-20 minutes and then you will send the email. Now, for such mails which have not followed up the SLA contract, basically they will be penalized, okay, or they will start imposing penalties to the companies saying that you are not following our agreement, you have breached the SLA, we are going to put so and so penalty, and those penalty will be in millions of dollars. It's not some few dollars, okay. So this SLA will be checked at the year end. So basically during the audit, they will see that how many SLAs were missed and then they will start imposing the penalties. Now, this is one-time investment, okay. So any company would think twice to pay penalty rather than investing on something which is after or giving a good customer output, right? So all the basic things was done on straight away from DNA. He's immediately triggering up the emails and he's sending it to the next person, and that's how the troubleshooting can also be taken care on DNA center, okay. Apart from this, we can also do various things like I have shown here. So when I do a ping, I get the ping output. When I see the OSPF neighbor, I can see the OSPF neighbor here. Okay, now if you see, this is stuck on a extract mode. Okay, so when a neighborship is stuck on extract, so the meaning is either MTU is not matched up. Okay, so this is clearly giving indication to someone, and to avoid any SLA breach, this is a good time investment. Okay, so if once the OSPF neighbor is checked, there is few more troubleshooting points like third, fourth, fifth, sixth. So basically, it's not just about basic troubleshooting. You can do some troubleshooting to some extent. Yes, so this was DNA center, which is getting integrated with your campus networks. Okay, so your campus network is required, which is acting as your underlay. Sorry. So, okay, 1 second. What is the time? Okay, we have 10 minutes, right? Okay. So what I'm telling is this is underlay, and over this we will keep we are going to keep overlay, and overlay is consisting of your DNA center, and we need to integrate this with your core. So basically on the core it must support VXLAN feature. Okay, and then we just configure. I'm not going through any configuration because CCNP is just about giving the overview of the architectures, like how in CCNA we had 2-tier, 3-tier, all those architecture. In CCNP it's the 2-tier, 3-tier, but yes, advanced thing. Now after SD access, next would be overview on SD WAN. Okay, so might be in the next class I will show you the architecture of SD WAN also. So don't expect any configurations or something. It's just an overview. I'm trying to give as much as a presentation so that you get cleared up. Okay, this DNA center you will not get it over internet. This has been taken specially for the batches. Okay, I mean for the batch purpose I have collected this. You will never get this somewhere. It's taken from some lab where we are doing this. Okay, so this is how your access SD access looks like. Okay, this is your DNA center which is getting integrated with your core or distribution layer. Okay, so in case of 2-tier architecture it is getting integrated with the distribution layer. In case of core layer 3-tier architecture, it is getting integrated with the uh, core layers. Okay, and yes, this is one more diagram to show you the working nature of SD access based on layers. Okay, so your physical layers are going to be as it is. On the network layers, especially your distribution layer and the core layer, is where you have to keep your SD access overlay, and it's a VXLAN which is going to integrate. Okay, then DNA center is one which is going to control the control plane, and then you have this DNA center GUI. GUI is nothing but graphical interface, which is going to take the management layer. Okay, all your design, automation, policy pushing, provision, assurance. Assurance is nothing but monitoring the devices, health monitoring. That is all done by the graphical interface, which is nothing but management layer. DNA center, which is doing control work, is nothing but integration with ICE server, Cisco ICE server for AAA. Let's say I have some policy created for wired connection users and wireless connected users, right? I'm creating some policy under Cisco ICE. Now that all comes under the control layer. Okay, so control layer act as your brain, and management is about monitoring, provisioning, policy checker, what is going on, if the policy is effective or no, or something is overriding it. Okay, this is VXLAN, which is integrating the overlay technology with the underlay. What is VXLAN? It's nothing but tunneling protocol, which is encapsulating layer 2 Ethernet frame in the UDP packet, layer 3 UDP packets, and then it's sent across the internet. Okay, that is a VXLAN technology. It's one data center in some location, this is on some other location, and this is a internet cloud. So we are extending the subnets, we are extending the L2 subnets from one data center to second data center. So this concept is again on data center topics. Okay, VXLAN, this is a data center topics. Okay, now this is a three-tier traditional network. That means without SD access, just a traditional. So what does traditional say here? So let's say this is my 3-tier architecture. Okay, the core distribution, access layer, and all the end devices. So it's connected with the another data center. It's connected with your SD WAN, but let's say it's not integrated. Okay, I'm just showing you that it's that your SD WAN is here. Oh, sorry, SD access is here. You have your internet connection here. You have your WAN connection here. What are the devices that this topology consists of? For access layer, that is this part, it's consisting of either 3K or 4K catalyst switches or 93 or 9400. So these are the advanced or the latest switches. 3K and 4K are end of sale. Okay. For distribution layer, that is this layer, we are using again 3K, 4K, 6K, and all the topics like your stack, all those things are as usual. Okay. I'm not going to repeat them. Just whatever we read in the starting of the class. So basically all those topics like stack. Okay. For a core node, we are making use of 6K, 7K and ASR 1K. Now this is something which I will show you in case of SD access. Okay. I'll show you in the next slide. For a centralized wireless LAN controller, which is somewhere here, we are making use of these controllers like 8540, 5520 or X800. Okay. For WAN, we are making use of ASR and ISR. ASR represent aggregated service router and ISR integrated service router. So basically, I have not covered different switch models and router models. So from beginner point of view, yes, I will take this class, it might be in the next class, where I'll show you different switch models and different router models. Okay, then only you will come to know these, what I'm talking about, these models. Okay. For internet edge, we have again the routers. Data center over here is all Nexus devices, 9K, 7K, 9K ACI. And for security, I'm using iServer, ASA, and Windows AD, administrator domain. So where is security coming in? So might be somewhere here. Okay, so wherever we need the firewall or wherever we need iServer, we will just plug it. Okay, so this is a traditional 3-tier architecture. Now let's say I get SD-WAN on this architecture. Okay, now what's going to happen? What are the extra devices I need for to convert this or to migrate this existing 3-tier architecture into SD-WAN 3-tier architecture? So in this case, these are this is the changes. So you may not see much changes because, as I told you, these were already connected. These are your DNA center, DNA. Okay, and these are integrated with your core devices, and those core devices now are called as fusion router. And what is the technology that these routers must have? VXLAN. Okay, and these are now your DC and internet borders. So basically you will have your ISP connections. Okay, so let's say from point of users who is accessing Google, he still have internet connection. They are not impacted by anything. This SD access is not about getting restricted or getting something. Okay, it's only about managing the enterprise in a better way. Okay, so these users still have their internet connection via this. Now if I want to impose any policy, if I want to create any policy, or if I want to monitor the health checkup of these devices, okay, if I want to create some security policy, let's say I want to create some layer 2 security policy here. I don't want to do the traditional way of CLI, each one of them. So for that reason, I'm getting these SD access, and then I can start pushing them. And you just saw how is the graphical interface of these. You can do monitoring, you can discover them, you can have the geographical discovery option, you have security imposed. Okay, and if you see the devices, these are all the devices. Okay, the one which we also used. Along with this, we are adding the DNA hardwares that I showed up in the previous screenshot, okay, or previous slides. Okay, now this is the official website for Cisco SD Access. In case if you're bringing up this business, or if you're bringing this technology to your enterprise, you can of course read this, or you can propose this to your management, and if they're really interested, they will get a team from Cisco who can give the demo or who can demonstrate this. Okay, so this is the official website for SD Access. Okay, all benefit, what are all the switches that SD Access supports. Okay, so let's go back to this. What are the benefit of SD Access? You can have a constant or a consistent management of wired and wireless. It's not that wired user will have some policy written and a wireless will have some policy written. Okay, your DNA is giving you provision to have a consistent policies for everyone. You're automating the network segmentation and you're grouping on based of policies. Okay, this means you can create VLANs. You can create the VLANs from DNA center only. You don't have to even log into any CLI, and you can group the user based on the policy. Like, let's say if he's from a sales, you can place, or let's say this is a user, he's having so and so policy enabled. Now if I have another user, it will not take me much time to give the same policy to this. I just have to replicate that. The same thing, if you do it on manually, you will see that sometimes some policy get messed up, or sometimes the policy don't get activated on a first try. Then we have to go back, raise the ticket, and then they activate manually. But with the help of DNA, whatever this person has, automatically this person will also get that. Okay, then we have contextual insight for fast issue resolution. So basically, as I told you, and capacity planning. So basically, why is it said that fast issue resolution? Because whatever goes down, you can see it on your dashboard. Okay, and you can start away, ping it, trace, or you can start troubleshooting. Capacity planning in the sense, if something is getting utilized beyond the threshold, you don't have to like go manually and see the interface, what is the drops, what is the RX or TX value happening on the interface level. On your DNA dashboard, it is clear by you can see on the health summary, where it will show you that this is the so and so health of this device. Let's say if the core is running at 90%, so this is very clear on your DNA center. But on a traditional box, you will not come to know until that device started dropping the packets, or that device started getting rebooted due to the high CPU utilization. Okay, in traditional, it is first impacted, then you take some action on that. But in DNA center, the motive is take the action first, don't let it to happen. Okay, that is the main thing here, to improve your quality of services. Okay, and then yes, you can integrate the third party software also, like if you have some syslog servers, or if you are making use of some other SNMP server, so this can be integrated with DNA. Okay, so that doesn't restrict you to use other services. Okay, again back to the same question, why SD access? Okay, even if you have not understood why SD access, so this is one more slide to demonstrate that. So basically, your network management spend 60 billion for your network operations. Okay, like outsourcing or your hiring of new network engineers. Okay, so this is some revenue which is being collected. There will be totally weekend changes up to 95%. Total 95% of changes in the weekends are done manually. 70% of the time, your policies get violated by human errors. That means you get some request for source and destination for TCP 22, but due to human error, you might have done it UDP 22. Now that's a bad impression on the network team, right? So that is what it says. Most of the time, like 70%, it's because of human error. Network churn, that means operational expenses. This is called as operational expenses on the visibility and troubleshooting. So basically, you're spending so much of amount on your operational expenses, right? Now, how is SD access going to help you? So basically, it's going to help because of all the things we checked in the previous slide on the graphicals, on the graphs, okay, that how is getting automated, how can we troubleshoot, how can we impose the securities. So I have another 1 or 2 slides and we will wind up. Okay, I know we have crossed the window. Okay, once again, quick revise. So your SD access components, this is DNA center and ICE for policy, and your network platform. Network platform is nothing but your campus design, which is underlay, and this act as your overlay. Okay, so this is the component of SD access. Okay, some SD access usual cases like security segmentation, we can do it from SD access. User mobility like policy pushing, all those things can be done from SD access. If there is a guest in our enterprises, we can create his policy or we can monitor his activities. Okay, internet over time integrations, which is like your when you're dealing with your internet, a lot of things you try to automate, right, without the interaction of humans. So basically those things can be uh, taken care by SD access. Monitoring, troubleshooting, cloud, data center integration, branch integration, troubleshooting, IoT, guest access, user mobility, security. Okay, so this is something which you can read later on. We have already covered that. It's just a summary of that. Okay, and the last thing is, what are you going to give back to your IT management with the by introducing SD access? Okay, reduction in network provisioning cost around 60%. You are reducing the network provisioning cost. Basically, provisioning is nothing but once a brand new device is plugged in a network, you have to poll them, discover them, reconfigure them, see if everything is in place, and then allow it for production. Okay, it involved hours, it involved field engineer, it involved the windows time. Okay, the change window time. Now using DNA we can cut down, so at least 60% of cut down we can see. Threat defense, reduction in cost, impact, security breaches. As soon as you get some DOS attack, as soon as you get some layer 2 attacks, you don't have to wait for them. Okay, your health checkup will keep on showing you that you are having a continuous attack from so and so IP, and you can immediately block. In traditional threat defense, what happens is, until there are some certain accumulated packets, only then it's going to trigger the notification. Okay, it's when we set some packet level like 100 packets. If we receive more than 1000, if we receive more than 200, then notify us about the attacks. Now in threat defense, since it's all graphical, we can see it piling up, and we can at least reduce 48% of such DOS attacks. Monitoring, troubleshooting, reduction in the cost to resolve issues. At least 80% you are helping your IT teams on your monitoring and troubleshooting the day-to-day activities of any service companies. Okay, and end user experience, you are increasing 40% of your end user experience. Okay, reduction in cost to optimize policies. So these are some benefits of SD access, and I guess you guys are now okay to ask any questions if you have.
Okay, let me ask just a short question.
Okay,
Is it agnostic?
sorry,
Is it agnostic?
I didn't get you, sorry.
Is it agnostic? DNA center.
Sorry,
Agnostic. DNA center, can it manage any other devices besides the Cisco devices? But like if
you mean to say multi vendors?
Yeah,
Yeah, you can do that. You can have multi vendor support. You can have your Windows server or Windows devices that gets integrated.
So you can manage the like for FortiGate firewall.
Yes. But yeah, you
access
can
points.
integrate. Only thing is how effective are they capturing those, okay, because this is a Cisco product and they are highly designed for Cisco devices only, okay. So there is chances might be FortiGate and Cisco ASA if the integration is not that effective, because I told you DNA is a new hardware. It will take some time to settle down. But yes, the main focus of Cisco is always to multi-vendor, because they don't want to fall into that bracket where they start losing the value. So they are always multi vendors only.
Okay. Thank
Hello,
you.
sir. I would like to mention that please consider the chat section as well.
Okay, yeah, sorry. Let me go through that, okay. Okay, so regarding the jobless scene, that is one misconception by every network engineers. Okay, why I'm telling this is because I am also part of network automation team. Okay, the main concern to automate is not to reduce the strength. Okay, it's to reduce the human errors. So let's say when I'm upgrading hundreds of routers in my enterprise, I might tend to do some mistake. Let's say this is a router which has to be upgraded to 11.1. This is to 12.2. This is to 13.3. Now during the change window, I get only 3 hours, and in that 3 hours, I might have 3 4 changes. I might end up doing some human error. That is, I might upgrade this version on this on this. Now this will be stuck on Roman mode. The device upgrade will fail. I will call the field engineer, I'll call the RMA, I'll do a lot of noise at that moment. I will lose my patience, and my all other 4 5 changes are piled up. They will not get executed, along with some production impact for next day. Now automation is not to cut down any job, instead to automate these things in much better way and much better planned way. Okay, so normally in automation what we do is, like, if you talk about legacy devices, we upgrade iOS routers. We push the configurations, any configuration of DHCP, configuration of logging server, configuration of OSPF. It's just to make sure that we don't make any silly mistakes. Okay, yes, there will be some impact, but again, network automation need a engineer at the back. Okay, it's not that you will automate and you will sit relaxed, because every step there will be something called checks. Okay, like once one script get executed, the engineer has to check whether that got triggered and successfully. Now the second thing, or the second step of that change will be carried again, the engineer will see if it is working fine, and then your complete automation will be done. So yeah, humans are involved, but only for inspection, not for doing any changes. Okay, so that is one thing what I would like to include.
So
Yes.
Sagar, let's say if a company has a team of 5 engineers and you have 100 routers to upgrade
Okay.
in 2 hours, so 20 routers per person.
Okay.
Let's say if we implement DNA and everything gets automated, the company would say, "Oh, I can cut down on my engineers and have only one guy do all 100 routers
Okay.
because it's automatic."
Okay, so if you see from that point, yes, but what if your company has other projects, like other project in the sense you're going to create a VPN for someone. Now that needs some expertise at the end. Like, see, creation of VLANs on DNA is okay. Your manager can do that. Let's say he's monitoring continuously the health checkup. That, let's say that also he can do that. But if he wants to configure VPN, now that is something which he will not be able to that. Even though you have automation uh, tools, you need some skill set who can do this job. So there can be some chances of reduction in the job if everything get automated, but yes, there should be some skilled resources as well. Okay, so that is why this enterprise, Cisco enterprise, is all about. It's not about only routing switching, it's about your wireless, your security, as well as routing switching, so that because nowadays enterprises are not dealing with only their local network. They will have multiple customer providing the services, VPN or some day-to-day services. So some or something which will be need the humans only, might be their own local.
Yeah,
Yeah,
I'm not saying
yeah,
that, but it's a start. So they're
yeah, yeah.
experimenting with DNA, with LAN, and other stuff.
Yes, yes,
Imagine in the future they come up with automated VPN, automated wireless.
yeah.
That's from that point
Yes,
of view
yes,
I'm
it,
saying.
it might get impacted. So the best thing is always upgrade. That is the one thing which I can tell, that upgrade yourself, upgrade to the latest technology like SD-WAN, AW,
Right,
yeah,
update your skill set.
AWS, yeah,
Hey, one more
yeah,
quick
yeah.
question. So you mentioned in the previous classes, in order to get CCNP certified, we need to do the core course and the NRC course.
Yeah.
But what if somebody wants to recertify? Does that person have to do both the
No,
courses or only one?
if you want to recertify, then I guess it's only one certificate. I
Which
think
one? The
the
core or
core,
the
no, no,
optional
only
one?
core. I think you have to only do the core, but I can get back to you regards to the recertification thing. Okay. Uh, what was
Okay.
the process earlier when there were three papers? So normally you had to write the next three papers, right? It wasn't one paper for recertification.
It was one. So if you have all
Okay.
three, and let's suppose it's expiring, you only had to do any one,
Okay.
not all
Okay, so
three.
in that case, this time also it might be only one paper, that is encore paper, not the concentration, only one paper. But yes, if you want to do CCNP certified, then you can do one encore and you can do any number of concentration. It's not limited to one. You have multiple option, NRC, SD-WAN, so you can do any one of them. Okay. Yeah, regarding these questions, DNA is much more than solar winds. Solar winds is more like monitoring only, okay, whereas DNA is more about diagnostic, configuration, analysis, reporting, a lot of things, okay, even automations. What is the difference between DNA center and Cisco Prime? So Cisco Prime, I am not very much sure. So let's see what is Cisco Prime. Okay, is it something older version? It says that it was uh, some older 2011 concept or something. Might be some tool used as a solar wind. Yeah, might be this is a solar wind for Cisco. Okay, which was a pretty older tool. But this DNA is a complete brand new, and it's much more than monitoring. Yeah, okay. Yeah. Okay. Fine. So, is there any question apart from this? Well, this is not a UCS chassis. Okay. These are a different hardwares specially designed for DNA models. If I show you this, so they have their own version. This is not a UCS server. There should be some somewhere the hardware number written. It should be some 64 something. Okay, so it's a special hardware which is used for DNA.
Hey,
Yes.
Sagar. If there are multiple sites in different countries, do we need this DNA box in every site, or just one device we need at like core site?
So basically, you can keep it over on cloud. I mean, you can integrate for a multiple locations, one DNA center. That is what that geographical graph was all about. So one DNA center kept on data centers, and then you have your IPsec VPN to all branches, and then that's how you can integrate between everything, and you can geographically discover the devices, and you can keep one single screen for everything.
Oh, okay, yeah, that's fine. It's not like a cloud key we use for like Unify that you have to have in every
No,
side. It's good
not
now.
that. Yeah.
Okay.
So what did you mean by when Cisco recommends best practice to have 3 DNA centers? What was that?
Yeah, so basically, what say for example, for ether channel technology, the best practice is it should be a count of or a multiplication of two, right? So like 2, 4, 6, 8. The best practice for ether channel is always keep 2, don't keep 3. For it doesn't mean that we cannot configure or bundle on 3, but the best practice always says 2. Similar way, for a DNA, to have your load balancing and all other factors, the Cisco recommends that to have 3. Even if one goes down, you have 2 working. If you keep only 2, might be if one goes down, then it's a kind of critical stage to trust on only one DNA or something. Okay, but yes, we can have 2. Okay, we can have 2. It doesn't say that we cannot configure on 2. We can, but the thing is, the best practice is to keep 3. So if you see this document, so this is how the best practice says that to have 3 data center connected. I mean 3 DNA centers connected. Okay, so the wiring in some this kind of order. Okay, so one more question over here. Would we perform the lab with routing topics for faster conversion instead of STP? So basically, routing topics are done over on routing only. We don't use STP. Okay, STP will be discussed during switching technology. Once we move out of the switching technology, it will be only routing, and we will be only making use of routing. Okay, we will be not using STP. So guys, we have done for the class. Okay, next we will meet up in the next class. Okay, so is there any doubt before I wind up? Okay, so I take it as no, and I'll pass on all the documents and the videos. So let's meet up in the next class. Okay, have a nice day. See you.
Thank you.
You too, Saga. Thank
Okay,
you.
thank you guys.